Chapter 11, Section 11.1, the objectives are to perform conversions between mass, mole, and volume. So let's review a few of the conversion factors that we should know. First of all, 1 mole is equal to the molar mass or grams of any substance added up from the periodic table. 1 mole can also equal 22.4 liters of volume of any gas that is at STP. So our map is going to be X gram, which would be milligrams or kilograms. You'll always want to change that to grams. From grams, we can change to 1 mole by going to the periodic table and getting the molar mass. 1 mole can be changed to liters using 22.4 liters, and liters can be changed to X liters, such as milliliters or centimeters cubed. There are also a few conversion factors that are worth committing to memory. 1 kilogram is equal to 1,000 grams. 1 gram is equal to 1,000 milligrams. 1 liter is equal to 1,000 milliliters. And 1 liter is equal to 1,000 centimeters cubed. So let's look at an example. Number 1, we are given 0.0680 moles of oxygen gas. Recall that oxygen is a diatomic and therefore the formula is O2, not just O. And they're asking us to find what is the volume in liters. So I'm going to put my given over 1 times, draw a line. Notice that we are starting at moles and they want us to find liters. So this is a one-step process. I'm going to bring down moles of O2, and from moles we're going to go to liters because 1 mole equals 22.4 liters of oxygen. Now I'll get my answer, 0.0680 times 22.4 is going to equal 1.52 liters of oxygen. Number 2, given 1.33 times 10 to the 4, which is what E stands for, times 10, milliliters, oxygen gas again, I'll put it over 1, times, draw a line. Bring down milliliters of oxygen, and notice that we are here at X liter. We're going to go from milliliters to liters of oxygen based on our map. We have to use the proper conversion factor. 1 liter equals 1,000 milliliters. Times, draw a line. Notice they want me to end up on mass, which is grams. So I'm going to bring down my liters of oxygen, and now I'm going to go from liters to mole. 1 mole of oxygen is equal to 22.4 liters. Times, draw a line, bring down mole. 1 mole is going to be equal to, and I'm going to go to the periodic table and add up the grams of oxygen. Oxygen is 16.00 grams per mole, and since we have 2 of them, it's going to be 32 grams of O2. Now we can get our final answer. .33 e to the 4 divided by 1,000 divided by 22.4 times 32 is going to equal 19 grams of O2. Number 3, what volume in milliliters at STP will be occupied by 0.0035 moles of methane? I'm going to put that given over 1, times, draw a line, bring down moles of CH4. It's always going to be 1 mole, and we're trying to get to milliliters. So first I'm going to go from moles to liters. 1 mole equals 22.4 liters times, draw a line, bring down liters, and then I'm going to go from liters to my milliliters. 1 liter equals 1,000 milliliters. Get my answer. 0.0035 times 22.4 times 1,000. And that gets me 78.4, and that's milliliters of methane. Number 4, we have 550 centimeters cubed, and this is of neon gas. So 550 centimeters cubed of neon over 1 times, draw a line. Centimeters cubed is here at X liter. So we're going to want to change that from centimeters of cubed is going to change to liters. We know that 1 liter is equal to 1,000 centimeters cubed. Times, draw a line. Now we need to know where we're supposed to stop. It says how many moles. So we still have to go another step, bring down liters of neon, and now I'll go from liters to mole. 22.4 liters is equal to 1 mole. And now we're finished. We can calculate our answer. 550 divided by 1,000 divided by 22.4 gets me 0.025. Moles of neon. Okay, number 5. I'm given 98.0 milliliters of sulfur dioxide. 98.0 milliliters sulfur dioxide. Put it over 1 times, draw a line, bring down milliliters of sulfur dioxide. Milliliters is here, and so we'll change from milliliters to liters first. 1 liter equals 1,000 milliliters. Times, draw a line. We need to know where we're going to stop, and they're asking what is the mass. So we'll be stopping at grams, which is 2 more steps from now. So bring down liters of sulfur dioxide. We want to go from liters to mole. And it's 22.4 liters equals 1 mole. Times, draw a line. I'll bring down mole. 1 mole is equal to, and I'll go to the grams and add up the molar mass of sulfur dioxide. Sulfur is 32, plus oxygen is 16 times 2, and so that's going to equal 64 grams of sulfur dioxide. When we calculate our answer, we get 98.0 divided by 1,000 divided by 22.4 times 64, and that gets us 0.28 grams of sulfur dioxide. Number 6, we have 7.08 moles of nitrogen gas. Nitrogen is a diatomic, so it's going to be N2. Over 1, bring down 1 mole of nitrogen. We're trying to get to what is the volume. So at mole, we have 2 options. We could go to grams, but we don't want to do that. We actually want to go to liters. 22.4 liters of nitrogen gas. So 7.08 times 22.4, and my total is 159 liters of nitrogen gas. We'll do one more example. Number 7 asks what volume is 77.0 grams of nitrogen dioxide gas. So 77.0 grams nitrogen dioxide over 1. Bring down grams of nitrogen dioxide. We want to go from grams to mole. Nitrogen dioxide is going to be 14.01 plus 16 times 2 which is going to equal 46. Times, draw a line, bring down moles of NO2, and from moles we can go to liter. 1 mole equals 22.4 liters of NO2. When we calculate our answer, you get 77 divided by 46 times 22.4, and that gives you 37.5.